Good afternoon, Ada, all the guest speakers, and everyone online. It's a real privilege to be back here and presenting. Our topic today is BIM to digitalizations of an airport city. I'm Guan, Senior Manager of the Runway Divisions, responsible for BIM implementations. A bit about myself. I started off in the construction fields, and then subsequently in the consulting fields for 14 years. And right now I'm with the Runway Divisions working on 3RS projects supporting all teams on BIM initiatives.
Hi everyone, I'm HanGyeol KIM. I'm a Senior Project Engineer of 3rd Runway Division, and I've been working for 3 runway system projects for more than 6 years by now. So from the AA BIM specification development stage to the detailed design development of the current 3 runway system project.
For the Digitalizations Awards, that was jointly prepared and submitted between AA BIM teams and our sustainability teams. So we are presenting the works from multiple divisions and also quite a few departments working together. So this will be our rundown for today. So we'll touch on BIM in terms of policy, people, process, technologies, and then we'll touch a bit of the great work of our other departments like operational digitalizations for sustainabilities, and digitalizations at city scales. So Airport Authority, AHK, we are a statutory body wholly owned by government of HKSAR, and we are governed by the Airport Authority Ordinance. One of our key missions is to foster a culture of innovations, to support the provisions, operations, developments, and maintenance of Hong Kong International Airports. As published online in the Sustainability Report 20-21, one could find the digitalization initiatives of our airport operations. Turning Hong Kong International Airport into a data-driven airport, such a comprehensive data collections framework is applied holistically across several areas like passengers and customers, traffic, operations, and maintenance. In 2015, AA envisioned that we need BIM specifications and standards to govern the executions of all our BIM projects during the design and construction phase. Thus, the AA BIM specifications developments started in 2015. Of course, the use of BIM in AA's projects began way before that. There are special disciplines like baggage handling systems, automated people mover, where such level of developments were not covered and defined in our specs. So we definitely see the needs of developing such. In terms of contractual requirements, one way that we foresee that we could help our contractors is to mandate the number of resources working on these projects. So that's why we put it as a contractual requirements. In the later years, more of these standards and specifications are defined, and we are also trying to align and constantly renew, update our specifications according to so. For now, AA BIM teams are formed ultimately to support not only in the runway divisions, there's also separate BIM teams be formed in engineering and technology divisions. So there's 2 other separate BIM teams leading and managing the BIM initiatives in E&T divisions. To date, we have around 14 CIC certified BIMers and coordinators. We tabulated there's around 550 BIM practitioners working on our airport city projects, locally and internationally. Employees empowering employees is an important factor in BIM implementations, and we've been focusing on trainings, thinking of ways to make the implementations are much more friendly and smooth ones. Where to assess the BIM models, hardware improvements, adequate support on a daily basis for our design and construction management teams, and also BIM management of all our design consultants and contractors is core function of AA BIM teams. Visualizations, collaborations, communications in all meetings using the forms of 3D and BIM models. especially during the pandemics. We have in-depth training set up for all project teams across different divisions and departments. So to date, we have trained around 810 man days, and we are insisting to continue to do this and push the figures up. We have around 2 to 3 hours of trainings, specific courses for our design and construction management teams, commercial teams, quantity surveyors, architects, engineers, and inspectors. We have a training center set up right in Terminal 1 in the air site.
So in AA context, BIM is a part of the broader digitalization process across the Airport Authority Hong Kong's operations and maintenance as well. So we, BIM team, always bear in our mind that ultimately we should achieve the digital twin for this purpose, and we should contribute to the digitalization of overall operations across the Airport Authority Hong Kong. So we in AA, we adopt the BIM use from the technical circular by work group and also the recommendations from the CIC BIM standard. The three runway system project is about 141 billion Hong Kong dollar project. So the number of the project that is implementing BIM is sitting at 45 plus. So all projects are mandated with bi-weekly submission of work in progress model, in addition to the drawing submissions and also the submissions for milestone BIM models. So there are well over 3,000 model files in the entire project every 2 weeks, and it requires tremendous effort to review and safeguard the models. So it is very important to automate the process based on the digitized information, and without such measures, it's fair to say that it's impossible to manage this project in terms of BIM. So this example shows how we cope with the clashes, and we automate the clash visualization process for our internal sharing, and to provide more insightful statistics of the clashes, we created an automatic workflow to measure the clashes based on the disciplines, rooms, and also the congestion levels. And in terms of the design, in 3D runway system project, we are implementing two major architectural projects. One is Terminal 2 expansion, and the other one is the Terminal 2 concourse. And it's very important to understand the architectural features in terms of the fabrication and logistics when it comes to the construction phase. So we devised this automation script to regularly review the design development of architectural features, so that we can understand the geometry, types, numbers, and also explore the possibility of the optimization. And this example is about reviewing the non-graphical information, which is another crucial aspect of BIM delivery. So in AA context, we define the necessary non-graphical information along with the design consultant and contractors for each project. So in order to review such information holistically, we automated the data extraction process from the federated BIM models. And also now we are starting further automate the reviewing process itself as well. And now we would like to present some of the works from our collaborators. So what they have achieved is that as we discussed in bi-weekly BIM progress meetings, we already expressed the importance of adopting this automation process in order to achieve the consistent data and ensure the right information is incorporated, and also the information in different documents are well aligned. So the first top left video shows the automation of the image recognition and text recognition that is applied to extract the information from a PDF drawing set to update the drawing registers automatically. And the top left corner is the synchronization between the synchronization of the viewpoint between Navisworks and also the common data environment, in this case Trimble Connect, so that we can streamline the clash resolution workflow, and also such synchronization enable us and contractor to work on the same page. And the bottom left corner case, this is to perform the CAD code check automation. Using CAD code in the spreadsheet and also the inputting the BIM model, we can automate this checking process, and we are also further studying a way to automate the incorporation itself, so that as CAD code is quite important, quite crucial for harmonization of BIM in overall Hong Kong context. So we are studying on this part. And the last example shows clashes mapped based on the coordinate, and which was used for reporting as well. So, and we specify the used languages in the slide for your reference. So what we are trying to do here is we are trying to cultivate the culture of sharing for this kind of knowledge, so that we can maximize the efficiency of the BIM implementation altogether. After all, software developers continue to include more automated functions in their as native functions that I've seen automation script often becomes obsolete. So we have our internal resources to work with design consultant and contractor as well on this matter, so that we can move into the right direction altogether. The next slide, the aircraft fire simulator is a classic example of the digital fabrication, and all elements were fabricated and assembled at a workshop in Guangdong province. So for manufacturing accuracy and ease of assembly, digital fabrication was adopted using CAD software called Tribon, and using the employer's model, the model was further developed with the necessary details, and also shop drawings were automatically generated, and steel plate were cut and curved using the data from Tribon to achieve the consistency between design and fabrication. They are assembled and delivered to the site for the installation, as you can see in the 4D simulation on the right-hand side. So other than that, AA plans to adopt and promote extensive application of DFMA, MIMEP, and also MIC in various areas of AA project. Next part is the GIS integration. So AA utilized the geospatial data management system for obstacle limitation surface management, meaning the altitude restriction for any object based on the location around the airport. And such GIS data is extracted and integrated with BIM and being checked if any permanent design and any of the construction equipment are clashing with such a surface. And it helps us to arrange the necessary exemption for any crucial construction activities. So this is one good example that BIM can unleash the computational capabilities. And the highest altitude monitoring system, the idea is quite similar. So HAMS is a platform that combines the data from sensors, GPS of all vessels in and out of the 3RS construction area and areas nearby. This platform monitors the location and altitude of any activities for any necessary warnings. And all contractors' vessels with air draft greater than 5 meters are required to equip this sensor for real-time monitoring system.
Okay. The airport runway is paved with multiple layers with a total thickness of around 1 meter in order to withstand the extremely high loads and tire pressure from the aircraft. So we have been thinking a lot about applications. We are doing a lot of modeling. We are doing a lot of coordinations based on BIM models. And how do we bring this data out to the field to help the contractors, right? So one application that is really worth mentioning is the machine control that we have applied over here. So the idea for pavement constructions is to install these machine control equipments, which includes some of these 2D displays, pitch, sensors, valve modules, 3D control box, 2D displays and targets, right? Together with the universal total stations for checking the alignments. So these BIM models designed by the consultants in Civil 3D, these are integrated into true open BIM concepts, integrated into these machine controls for digital constructions. This includes all the setting outs, laser scannings are done to double check the qualities, right, together with our survey teams. So overall, here's one video, that, just a quick glimpse of the machine controls. Here's the final product. The CX cargo flights from Shanghai was the first commercial flight to land on third runway in July 2022.
Next part is the reality modeling. So in the process of the implementations, photogrammetry was adopted to capture and visualize the progress. And such information is shared for our stakeholders so that they can understand the progress of the project. And the next one is And next one is the as-built modeling exercise using the laser scanning for as-built verification. So, and verification of the built element against the design. So AEA scan the existing terminal, like existing facilities like Terminal 1, and we also require the scanning for all E&M, UU, structure, and architectural element on the 3 runway system project. So we are confident to say that it's the largest scanning exercise within Hong Kong. And one thing to be wary of this is the time limitation, for example, the backfillings. So this is an ongoing exercise that eventually the whole 3 runway system project will be scanned for the record. And next part is the digitalization works done by other department of AA in collaboration with local institutions for developing real-time trolley supply monitoring system.
Hong Kong International Airport is one of the world's busiest airports. At HKIA, more than 100 airlines operate over 1,100 flights every day, connecting passengers to over 220 destinations worldwide. In 2017, the airport handled 72.9 million passengers, which is an average of around 200,000 passengers per day. To handle such high passenger and baggage flow, HKIA has 13,000 luggage trolleys to serve passengers' needs. One of the challenges faced by the airport is ensuring the sufficient provision of trolleys at various pickup points throughout the terminals for passenger use. HKIA used to manually inspect trolley racks for availability. However, this was not very efficient in such a large airport. In 2017, HKIA introduced the Trolley Management System, which adopts artificial intelligence and video analytics technologies to track trolley supply at each pickup point in real time. Individual trolleys can now be detected in video content from CCTV using the machine learning technique. After summing up the number of available trolleys at each rack, the data is immediately transmitted to the monitoring system and mobile app.
With the mobile app, the trolley contractor can know any trolley shortage at specific trolley pickup points in real time. They can then deploy trolley assistance to replenish the trolley racks accordingly.
The trolley mobile app uses red, yellow, green color codes to summarize the real-time status of various pickup points. Red indicates an empty pickup point, which requires immediate replenishment of trolleys. Yellow indicates a likelihood of trolley shortage, while green means there is a sufficient supply of trolleys. In addition to the mobile app, the system also provides analytics and visualization tools to track the demand and supply patterns of trolleys in different scenarios. The analysis from the trolley demand and supply data may provide insights into better resource management at this dynamic airport. HKIA has been named the world's best airport more than 70 times, and its key to success is placing great care in every single detail of its operations.
And the next part is the HGL, Airfield Ground Lighting System. This system serves as the visual aid for pilots to take off, land, and taxiing the aircraft during the night time. So the maintenance is quite important, and there are about 14,000 fixtures around the airport. So developing the scanner, the operation department could easily identify the defective HGL object. And AEA is planning to invest another 50 million in further development of autonomous driving technology. And we are the first airport that deploy autonomous baggage tractors in the live airport operation environment. And there are more to come. For example, the autonomous patrol cars.
Digital twins. So for the past 15 years, we've been handling 2D CADs, right? Transforming from 2D CADs to BIM and then to GIS. We have spent huge effort in digitizing all the existing terminals and concourse. The BIM teams are ultimately the keepers of all the BIM data. And for new design construction contracts, we are applying full BIM users, especially for 3 runway systems. All of this data will be subsequently handed over to our engineering and technology teams, our asset management. One of the major roles is to ensure the upkeep and the maintenance of the assets. Facility managers, management officers are always tasked with different challenges. So for data capturing, business plannings, project deliveries in terms of design and constructions, and operation plan maintenance, each cycle plays an important role in the corporate. This is showing one of the platforms and one of the initiatives from my counterpart in terms of BIM and asset management. It's really creating these service requests in the 3D environments, monitoring faults, system performance, and so on. There's also work orders. integrated marine traffic control centers. So basically, the MTCC was set up on site so that this is set to monitor all the marine traffics, and then and all the construction works for the DCMs for 3RS projects. Automatic identification system AIS transporter was installed on the vessels so that every 30 seconds this data have been sent back to MTCC. Personnel working on the projects, they have access to the platforms or even using smartphones or tablets for these real-time monitorings. For sustainabilities, right, a range of these biodiversity conversations and enhancement initiatives are being implemented as part of the long-term efforts to protect and enhance various habitats and environments around HKIA. So one of the implementations is definitely the dolphin exclusion zones using the CCTV monitoring systems. A second part is one of the trials being done by AA was the robotic and AI-based intelligence robotic waste sorter systems at T1 Terminal Concourse. That was done in March 2021. So the trial involves sorting of general waste, recyclables from HKIA to test the capabilities, efficiency, and limitations of the system on various settings with an aim to identify the most optimal operating environment and improve HKIA's waste recycling performance. In terms of recommendations, for recommendation projects, there's a lot of these monitoring sensors being, these monitoring systems being installed, especially for the seabed monitorings. These include the vertical shape arrays to monitor the lateral movements of the seabeds, including the horizontal shape arrays that was installed. Within all our design consultants and contractors, our partners, so we calculated around the 68 collaborators to date. So and there's more. My apologies if I not included all. Thank you all. And thanks to my teams, especially my counterparts, Frocky's teams from Technical Services, Kevin Wen's BIM team from Capital Works. So all this award goes to you all, and to my ex-colleagues working on 3RS projects. Okay, last part, seabed. This is the last clip.